Welcome to the Metabolic Maestro podcast, where we help you orchestrate your metabolism one note at a time. This is episode 9, Energy Buffers, Creatine, Glycine, and Taurine in the Muscles and Brain. I'm Kathleen, a synthesized voice Bob has chosen to host his podcast. Welcome back to the Metabolic Orchestra series, the 9th episode in this series. Previously, we've covered electricity, adenosine triphosphate ATP, mitochondria, redox balance, minerals, hormones, and today we focus on the buffers. Energy production is fragile, ATP is fleeting, mitochondria can be overloaded and depend on creatine, glycine, and taurine as safety nets in muscles, neurons, and organs. Part 1. Creatine, the instant energy reserve. Your cells face a fundamental problem. ATP gets used up in milliseconds, but oxidative phosphorylation takes seconds to minutes to replenish it. This is where creatine serves as your emergency phosphate reservoir, bridging the critical energy gap. When you sprint, think fast, or power any high-demand tissue, ATP is split into ADP within the first second. Creatine phosphate immediately donates its phosphate group to ADP, regenerating ATP in a fraction of a second with no oxygen required. This rapid phosphate transfer is what keeps your muscles contracting during a deadlift, your neurons firing during quick decision-making, and your heart beating steadily under stress. Without adequate creatine, your cells literally run out of usable energy within the first few seconds of intense demand, forcing you to slow down or stop while your mitochondria struggle to catch up. Part 2. Creatine, the brain's energy buffer. Your brain runs primarily on oxidative phosphorylation, the slow but steady power plant that fuels constant neural activity. But what happens when you need a sudden burst of mental energy, like solving a complex problem or reacting to danger? That's where creatine becomes essential. Acting as an immediate energy buffer, creatine donates its phosphate group to rapidly regenerate ATP right where neurons need it most. This quick access energy supports neurotransmission, maintains critical ion gradients across cell membranes, and ultimately reduces mental fatigue when you're pushing your cognitive limits. While your brain can make its own creatine from glycine, arginine, and methyl groups, this endogenous production isn't always enough. Fortunately, dietary creatine readily crosses the blood-brain barrier, directly supplementing your neurons' energy reserves and ensuring your brain can handle both marathon thinking sessions and short sprints of intense focus. Part 3. Glycine, the cleaner. Creatine can buffer energy, but electrons still leak from the electron transport chain, creating reactive oxygen species that pollute your cells. Glycine serves as your mitochondrial cleanup crew, tackling this oxidative damage head-on. By forming glutathione, your body's master antioxidant, glycine neutralizes these harmful molecules and maintains the redox balance that keeps your energy production running smoothly. In your muscles, glycine goes beyond cleanup. It supports protein synthesis while reducing inflammatory signaling, helping you rebuild stronger with less metabolic waste. In your brain, glycine plays a different, but equally crucial role as an inhibitory neurotransmitter. It calms hyperactive neural circuits, reduces excitotoxic stress, and ultimately improves the efficiency of your brain's energy use, preventing your neurons from burning out. Part 4. Taurine, the stabilizer. When your cells work hard, ions flood across membranes in chaotic waves. Calcium, sodium, and potassium surge in and out, threatening to overwhelm your mitochondria and disrupt the delicate electrical balance that powers every contraction and thought. Taurine acts as your cellular stabilizer, gently regulating these ion channels to prevent overload. During intense activity, Taurine keeps muscle contraction smooth and controlled rather than twitchy and erratic. In your brain, it ensures neurons fire with precision instead of devolving into electrical chaos. It even shores up mitochondrial membranes themselves, preventing them from becoming leaky and inefficient when energy demands peak. Beyond this direct stabilization, taurine supports bile acid conjugation, helping you digest fats that fuel your mitochondria, and bolsters antioxidant defenses, creating a secondary layer of protection for your energy metabolism. Part 5. How they work together. These three nutrients operate as a synchronized team, protecting your cellular power plants. Creatine stands ready as your instant energy reserve, providing rapid ATP when demand suddenly spikes. But this burst of energy production inevitably creates metabolic waste and reactive oxygen species. This is where glycine steps in, forming glutathione. To neutralize these damaging byproducts and maintain the redox balance essential for efficient energy flow. Meanwhile, taurine works behind the scenes as the system stabilizer, regulating ion channels and reinforcing mitochondrial membranes against the stress of high activity. Together, this trio prevents the energy collapse that would otherwise occur when demand exceeds supply. They reduce the fatigue that comes from oxidative damage, support faster recovery by protecting cellular structures, and maintain the delicate redox balance that keeps your mitochondria humming. When any one of them is missing, the entire system falters. Energy efficiency drops as mitochondria struggle without backup power. Reactive oxygen species accumulate unchecked, damaging membranes and DNA. Both physical performance and cognitive function suffer as cells become polluted, and unstable all at once. Part 6. Nutrient dependencies. These energy-supporting nutrients don't materialize from nothing. They're assembled through intricate pathways that depend on a host of other molecules. Creatine synthesis requires glycine, arginine, and methyl groups from S-AME. Glycine production needs adequate protein, functional mitochondria, and magnesium to proceed. Taurine synthesis depends on cysteine and vitamin B6. All three pathways share common dependencies: iron for mitochondrial enzymes, vitamin C for electron flow and antioxidant recycling, potassium for maintaining ion gradients, and magnesium for ATP function itself. This reveals the central truth of energy metabolism. It's not a linear assembly line, but an interconnected network where no molecule works in isolation. A deficiency in just one mineral can ripple outward, compromising your entire energy system. Part 7. Age and tissue demand. As we age, our bodies quietly lose capacity across the entire energy network. Creatine stores naturally decline, glycine availability drops, and taurine synthesis slows to a crawl. These deficits don't affect all tissues equally. Your highest energy organs feel the impact first. Your brain begins to show cognitive fatigue, struggling with focus and mental endurance. Your heart, that perpetual motion machine, loses contractile strength, making every beat slightly less efficient. Your muscles recover more slowly, with lingering soreness and reduced power. The good news is that targeted supplementation and nutrient support can partially restore this lost capacity, helping your cells recapture a fraction of their youthful energy production. Part 8. Exercise and buffer use. During intense activity, whether you're sprinting or lifting heavy objects, your cells burn through their ATP reserves in the very first second. For the next critical window of 1 to 10 seconds, creatine phosphate serves as your emergency backup, rapidly donating its phosphate group to keep ATP from collapsing. While creatine handles the immediate energy crisis, glycine and taurine work behind the scenes. Glycine mops up the wave of reactive oxygen species generated by this metabolic firestorm, while taurine maintains the delicate ion gradients that keep your cells electrically stable under stress. Without adequate levels of these buffers, the story ends differently. Energy collapse happens within seconds, leaving your muscles weak and your neurons misfiring. Recovery stretches from minutes to hours as your mitochondria struggle to repair the oxidative damage inflicted during the unprotected effort. Part 9. Dietary sources. These energy buffering nutrients come from both your diet and your body's own assembly lines. Creatine arrives primarily from red meat and fish. Those supplements provide a concentrated alternative for those who don't eat much animal protein. Glycine flows from collagen-rich foods like bone broth, as well as from meat, fish, and legumes. Your body can also synthesize it, but this process demands magnesium and robust mitochondria, ironically, the very things glycine is meant to protect. That's because you need healthy mitochondria to make glycine, but you need glycine to keep mitochondria healthy. It's a vicious cycle. Taurine is abundant in meat, fish, and shellfish. If your diet falls short, your cells can manufacture taurine from cysteine and vitamin B6, but this pathway becomes less efficient with age. The final balance in your tissues depends on a delicate equation: how much you consume versus how effectively your cells can build these molecules themselves. When either side of this equation falters, your energy reserves quietly deteriorate. Part 10. Takeaways for energy efficiency. Creatine, rapid energy delivery. Glycine, mitochondrial cleaning. Taurine, membrane and ion stabilization. Minerals and vitamins, required for function. Hormones, determine timing and direction. These energy systems are integrated networks. Supporting buffers improves efficiency, reduces oxidative stress, and preserves mitochondrial function. In closing, muscle and brain demand bursts of energy. ATP alone cannot meet the need. Creatine buffers, glycine cleans, and taurine stabilizes. Together, they ensure energy is safe, efficient, and sustainable. In the next episode, we'll explore fat metabolism, mitochondrial flexibility, and how nutrients and hormones shape fuel choice. Until then, energy is not only production or protection, it is orchestration.